So in the previous video we have talked about the first shifting rule and some standard formulas regarding the Laplace transformation. Now in this we will see the another formula like multiplication with t power n. Okay, so what is the theorem? Theorem is like if L of f of t will be equal to f of s, then L of t power n f of t will be equal to minus 1 power n d by ds of n f of s. So this is basically called as multiplication with t power n. Okay, so let us understand more clearly with an example. So L of t sine 80. So this is in the form of multiplication of with t power n, where n is equal to 1 here. Okay, so we know what is the formula. L of t power 1 sine of 80 will be equal to minus 1 power n. So n is here 1, so minus 1 power 1 d1 by ds1 f of s ds. So what is the Laplace transformation of sine t? It is a by s square plus a square into this. Okay, now so minus 1 will remain minus 1, and what is the derivative of a by s square plus a square? See, so it is the form of u by v. Okay, so it is like v into u ka derivative. So derivative of a with respect to s is 0 minus, so v into u ka derivative minus u into v ka derivative. So s square by s square plus s square plus a square ka derivative is 2s divided by s square plus a square ka whole square. So this will be 0, and we are left with 2as by s square plus a square whole square. So this is our answer. Now let us solve one more problem. Like the question is, you need to find a Laplace transformation of t cos 3t. Now how to do this? Here also n will be 1, and your f of t will be cos 3t. So your f of s will become, so what is the Laplace transformation of cos 3t is s by a square plus s square. So your s by, so a is 3, so s by s square plus 3 square is 9. Okay, now put the values in the formula. So minus 1 power n d by ds of n, so it is 1 1 f of s. So f of s is s by s square plus 9. Okay, now we need to perform the derivative of this function. So we'll get minus 1 power 1, so v s square plus 9 into u ka derivative. So derivative of u is 1 minus v into u ka derivative minus u into v ka derivative. So derivative of s square plus 9 is 2s divided by s square plus 9 whole square. Okay, so minus 1 s square plus 9 minus 2 s square divided by s square plus 9 whole square. Okay, so we get minus 1 9 minus s square divided by s square plus 9 whole square. Now if we multiply with minus 1, then we'll get s square minus 9 divided by s square plus 9 whole square. This is our answer. Okay, so such kind of derivative you can solve this by using this method. Let us solve one more interesting question. So question is like you need to find the value of integration 0 to infinity e power minus 4t into t cos 3t dt. Okay, so in this question, if we clearly observe, it is some form of integration 0 to infinity e power minus st f of t dt, which is the definition of Laplace function of f of t. Okay, now so if we compare both the terms, then our s will be equal to 4 and our f of t will be t cos 3t. So our integral becomes the Laplace transformation of f of t. So So this, the value of this integral is Laplace transformation of t cos 3t. So in just above question we have seen that what is the Laplace transformation of t cos 3t. It will be equal to s square minus 9 divided by s square plus 9 whole square. So our value of s is 4. Okay, so 4 square minus 9 divided by 4 square plus 9 whole square. Okay, so it is 16 minus 9 divided by 16 plus 9 whole square. So 16 minus 9 will be 7 and 16 plus 9 will be 25. 25 will square with 625. So 7 by 25 is the answer. 7 by 625 is the answer. Okay, and so you can solve such problem like this methods. Okay, so let us understand one more concept. So there is one more concept. It is called as division by t. Division by t. Now what is division by t? So if L of f of t will be equal to f of s, then L of f of t by t will be equal to integration s to infinity f of s ds. So this is called as the division by t. Okay, let us understand this concept with example. So the question is, you need to find the Laplace transformation of sine at by t. Okay, so in this question your f of t will be equal to sine at. So this function is in the form of the above formula that we have looked. So the value of L of sine at by t will be equal to integration s to infinity f of s ds. So what is f of s? F of s is Laplace transformation of sine at, which is equal to a by s square plus a square. So put the value of this in this, so we get integration s to infinity f of s. F of s is a by s square plus a square into d of s. Now a is constant, we can take it outside, so it is a integration s to infinity 1 by s square plus a square ds. Okay, so the integration of 1 by s square plus a square is 1 by a tan inverse x by a. Okay, so it is a into 1 by a tan inverse s by a, and your limit is from s to infinity. So a will get cancelled, we'll get tan inverse infinity minus tan inverse s by a. Tan inverse infinity will be pi by 2, so pi by 2 minus tan inverse s by a. So pi by 2 minus tan inverse s by a is cot inverse s by a. So this is our answer, cot inverse s by a. Okay, so with this concept, let us solve one question. So the question is, you need to find the value of integration 0 to infinity sine at by t dt. Okay, so you need to solve this integral. So how to solve this integral? Okay, so let us understand the problem. uh, so you can write Laplace transformation of sine at by t is equal to the standard definition that we are having, integration. So L of f of t is nothing but 0 to infinity e power minus st f of t. So sine at by t dt. Okay, which is equal to cot inverse s by a that we have solved recently. Now if in the above integral the value of s will equal to 0, then integral become Laplace transformation of sine at by t is equal to integration 0 to infinity. So if s is 0, then this term will become 1 and we'll get sine at by t dt, which is equal to cot inverse s by a, and since our s is equal to 0, then we'll get cot inverse 0. Okay, so the value of cot inverse 0 is nothing but pi by 2. So our integration 0 to infinity sine at by t will be equal to pi by 2. Cot inverse 0, that is pi by 2. This is our answer. Okay, so in this video we are ending this. In the next video we will see the differentiation. the Laplace transformation of the derivative of any function. Okay, so thank you.